Okay, next question is about iterative formula. The diagram shows y is equals to x times e raised to the power 2x minus 5x and its minimum point is m whenever your x is equals to the value of some alpha, that is maybe any constant. Showing that alpha satisfy following equation such that alpha is equals to 1/2 ln of 5 over 1 plus 2 of alpha. First of all, you have to consider the definition of minimum point. Minimum point means your first derivative dy by dx should be equals to 0. You have to consider the first derivative first in order to calculate the minimum point. Minimum point is also known as stationary point. So you have to calculate the dy by dx first. So once you calculate dy by dx, then you have to put x is equals to a, and then at the end you are able to prove that equation. Anyways, you have to calculate dy by dx first. So that is your equation. Let's calculate the dy by dx so far. So y is equals to x times e raised to the power 2x minus 5 of x, and calculate the first derivative for it. You are able to get dy by dx is equals to, this is x e raised to the power 2x. It means that you have to apply the product rule. So the derivative of x will becomes 1 and e raised to the power 2x will retain as it is, plus first function retain as it is, and the derivative of second function, that is e raised to the power 2x. E raised to the power 2x times by the inner function derivative, that is 2, minus the derivative of minus 5x, that will become obviously minus 5 only. And you are able to get dy by dx of the form e raised to the power 2x plus 2x e raised to the power 2x minus of 5. That is the form of dy by dx. Okay, because this is a minimum point, means the stationary point, so its dy by dx should be equals to 0. So at this place I am going to put 0 over here, and I have e raised to the power 2x plus 2x e raised to the power of 2x minus 5. What you have to do now, you have to take e raised to the power 2x common, that you can from the first two terms. Once I took e raised to the power 2x common, inside I have 1 plus 2x and minus 5 will retain as it is. Okay, next, the thing that you can do, dy by dx is equals to, or you can also say e raised to the power 2x times by 1 plus 2x, shift 5 onto the other side, that will become positive of 5, and you have to take your answer in terms of x, so definitely that will become e raised to the power 2x, which is equals to 5 over 1 plus 2x. You want to get rid of that e because you have to subject your equation in terms of x. If you go back to the question, you can see you have to subject your equation in terms of x, and x would be treated as alpha once you put the value of x as alpha. So you have to subject your equation in terms of x only. So apply anti-log over that equation just marked as equation number 2, and apply the anti-log over here. So ln of e raised to the power 2x, which is equals to ln of 5 over 1 plus 2x. 2x could be shifted front because of the ln property, just like ln of e raised to the power ax could be written as a times ln of e raised to the power ax could be shifted at the front, and you can see ln of e would be treated as 1, and it will retain only a times by x. That was the log property. So you are able to get 2x ln of e, which is equals to ln of 5 over 1 plus 2x. ln of e will retaining into 1, and you have x is equals to 1 half ln of 5 over 1 plus 2 of x. Get that expression? Now you have to put the value of x as alpha, because you have to consider the final form in terms of minimum point whenever your x value is retaining into alpha. So put that you have to prove so far. Let's check. Yeah, that one. You prove it. In this way you can get the answer for the A part. For the second part, what you have to do, verify by calculating the value of alpha, and you have to show that its answer should lying between 0.4 to 0.5. You have to consider the equation that you prove in the A part, that is equation number 1. So just like write it down. Alpha is equals to 1 by 2 ln of 5 over 1 plus 2 of alpha. That is the value that you get from the A part. You have to put the value of alpha as 0.4 first time, and second time you have to put 0.5, and you have to observe either your answers are lying between them or not. So you can do alpha minus 1 by 2 ln of 5 over 1 plus 2 alpha, which is equals to f of x, or you can say f of alpha, you can also say. For the first time you have to put the value of alpha as 0.4 over here. So once you put the value of alpha as 0.4, your answer would reduced into 0.4 minus 1 by 2 ln of 5 over 1 plus 2 times by 0.4, and let's check what is the answer you get on your calculator. 0.4 at the value of alpha, once you are 0.4 you are putting, your answer is basically coming as, let me do on my calculator, it's coming as minus 0.1108. That is the first condition at the alpha 0.4. For the second time you have to put the value of alpha as 0.5. So once you put 0.5, you are able to get 0.5 minus 1 by 2 ln of 5 over 1 plus 2 times by 0.4 f of 0.5. So here is 0.5. So once you are putting the value of alpha as 0.5, let's do on your calculator and see what will be the answer. Your answer for 0.5 will be coming as 0.4, 0.5. That is the answer for alpha 0.5. Now you have to check either your both answers are lying under the range, means between 0.4 and 0.5. So for 0.4 your answer is negative, means 0.4, f of 0.4 is less than 0. But for f of 0.5 your answer is greater than 0. It means your answer is lying under the range. Since you have the value is lying between, it means that alpha is lying between 0.5 to 0.4. That's hold. Okay. Now listen to me here. Some of the students did mistake, like they are considering like f is equals to ln of 5 over 1 plus 2 of alpha, and they are putting only the value of alpha over here, just like this is out here. They are not considering that part that I'm going to highlight. They are just treated as f of alpha. ऐसे नहीं करना है, because जो आपने फर्स्ट पार्ट में प्रूव किया है, that is alpha is equals to 1 by 2 ln of 5 over 1 plus 2 alpha. When you see that just considering that thing and ignoring the left hand side. You can't do that, that will be completely wrong. So you have to be sure about it. You must have to consider the right hand side alpha and left hand side alpha so that you can get the accurate answer. Third part.